Okay, good morning dear students. Welcome for the physics class. So, in the previous class we are explaining about the physical world. We are discussing about the physical world. Right? So, today we will discuss about the physics for technology and the physics for society. That means how physics will be interrelated to the technology, how the physics will be used to develop some technology, and how the physics will be helpful for our society, means our day-to-day life. Okay? So, physics for technology. Physics for technology. So here in the physics we have number of laws, okay, number of theories. Based on those laws or theories, particular technology has been developed. Okay, and in this class we'll just study or we'll just discuss which are those laws which is a technology, and detailed study of those laws we will pursue in the upcoming chapters. The first one is Newton's law of gravitation. Newton's law of gravitation. It is one of the most important and a very famous, familiar law in a physics that we are going to study in our 8th chapter, that is gravitation. Okay. So here this Newton's law of gravitation will help us to develop and the launch of artificial satellites. In order to launch the artificial satellite, we must have the knowledge that with what velocities they have been projected from the surface of the Earth in order to overcome the gravitational force of the Earth. So at some distance, they'll travel under the influence of gravitational force, and they will come out from that gravitational force, and they'll start revolving around the Earth, the artificial satellites. So this launching of artificial satellites will be done with the help of Newton's gravitational law. That is the first thing. Okay. And second one, thermodynamics. We'll study it on upcoming chapters. Okay, the law of thermodynamics will be used to design the engines like heat engine, petrol engine, diesel engine, and refrigerators. These are all designed. The diesel engine and the petrol engine, heat engine, and the refrigerators. So these are all designed based on the or with the help of law of thermodynamics or a study of thermodynamics. Okay, and next we'll have hydrodynamics. By the study of hydrodynamics, we can design or we can construct a vehicle and aircraft. Okay, aircraft and the vehicles are constructed with the help of the study of hydrodynamics. Okay, so hydrodynamics is also a concept of physics. So what it means, we'll study later on. Okay, and then we have the electromagnetic waves. Electromagnetic waves means the light wave, it is also electromagnetic wave. X-ray, it is also electromagnetic wave. And ultraviolet waves, infrared waves, these are all electromagnetic waves. By the study of propagation, means motion of these waves, we can design the instruments like the radio, television, and the wireless communication systems such as mobiles. Okay, so here mobiles, television, and radio, these are designed by studying the propagation of electromagnetic waves. brief what concept of physics related to technology. So first one is what? By the study of Newton's gravitational law. Newton's gravitation law, which helps us to launch the artificial satellite. Okay? Helps to launch artificial satellite. And second one, the study of thermodynamics helps to design the engines like heat engine, diesel engine, petrol engine, and refrigerators. Thermodynamics means it is the study of heat, concept of heat. Okay. Study of thermodynamics helps to design engines like heat engine, diesel engine, petrol engine, and refrigerators, etc. Refrigerator is the fridge which you are going to use in your home. And third, here, study of hydrodynamics. Hydrodynamics helps to design vehicles and aircraft. Fourth one, the study of propagation of electromagnetic waves help to design radio, television, and wireless communication. Wireless communication. So, this 4 points will explain about how the physics has been linked to technology, how it is helpful for technology. And apart from them, in the notes, which is I'm going to send now, apart from these points, we will get number of uses or the link between physics and technology. We just go to that one. And next, physics for the society. How the physics is helpful for the society? So already from these points, we have learned that the artificial sunlight because of physics, and the petrol engine, diesel engine, the heat engine, the refrigerators, all are because of physics, and television, radio, wireless communication is because of physics, and here the design of aircraft and vehicles is also from the physics, based on the laws of physics. Okay. So then, from these points, we'll move towards the physics for the society. How it is helpful for the society? So look here, we can travel very fast with the help of aeroplanes. With the help of aeroplanes. But the aeroplanes, the construction of aeroplane is involved the laws of physics. Okay, and we can enjoy the color television. We can watch the color television. So that construction or design of television is based on physics, or the laws of physics. Okay, and we can use our mobile phones. The wireless communication is based on the satellites. But the launching of satellites is purely based on the laws of physics. Okay, and one more, the very important, the communication. The computer. The computer which can solve the complex problems very easily. So that computer is also by the physics only. So, and we can use electricity to operate many electrical devices. That electricity is also from physics only, right? So these are some of useful aspects of physics for the society. Is it clear? And next, we'll go towards the fundamental forces in nature. So I think in the first class only I have explained some concepts about the fundamental forces. Now we'll study a detail about those fundamental forces. So the fundamental forces in nature, the basic forces in nature. The first one is known as gravitational force. And next one is electromagnetic force. Electromagnetic force. And third one is strong nuclear force. Fourth one is weak nuclear force. So these are the four fundamental forces in nature. Okay. Before explaining all these forces, I want to clear some points. Okay. Please remember, in the universe, in the nature, the very weakest fundamental force is the gravitational force. Weakest, which is weakest fundamental force, which is gravitational force. And the very much strong, the strongest fundamental force is strong nuclear force. Strong nuclear force is the strongest force in nature. Okay? They may ask in examination, which is the weakest fundamental force in nature? That is gravitational force. Which is the strongest fundamental force? That is the strongest nuclear force. So just tell you some data. So look here, the electromagnetic force. The electromagnetic force, it is 10 to the power 36 times stronger than gravitational force. So look here, this electromagnetic force, it is the stronger force than the gravitational force. How much it is stronger than the gravitational force? It is 10 to the power 36 times stronger than the gravitational force. That means in front of 36 zeros. 36 zeros. That much time this electromagnetic force is stronger than the gravitational force. Is it clear? And then next, the strong nuclear force. The strong nuclear force, it is 100 times stronger than electromagnetic force. Electromagnetic force. Look here, electromagnetic force is 10 to the power 56 times stronger than the gravitational force. But strong nuclear force is 100 times more stronger than the electromagnetic force. You can imagine. Okay? Right. Next is weak nuclear force. Weak nuclear force is stronger than gravitational force but weaker than electromagnetic force. Okay? Are you getting this point? The weak nuclear force is stronger than gravitation but weaker than electromagnetic. Then we'll write a ascending order of these forces. The very weakest force is gravitational force. The little bit stronger force compared to gravitational force is weak nuclear force. Little bit stronger than weak nuclear force is electromagnetic force, and the very strong force compared to all of these is strong nuclear force. Is it clear? Okay. Now we come to the gravitational force. What do you mean by the gravitational force? It is the force of attraction between any two particles in this universe. Look here. Gravitational force means it is force of attraction between the particles in this universe. All the particles which are present in this universe will experience the force of attraction by the surrounding particles, and that is called as the gravitational force. Is it clear? So, and this gravitational force is always attractional force. It is always attractional force. Next, electromagnetic force. So, electromagnetic force means it is the force between the charged particles. It is the force between the charged particles. For example, the force between electron and a proton, that is electromagnetic force, and the force between proton and proton, that is also electromagnetic force. Okay? So here electromagnetic force means it is the force between charged particles. And here the nature of this electromagnetic force may be attractive or may be repulsive. It may be attractive or may be repulsive. Is it clear? Okay. Then next comes to the strong nuclear force. What do you mean by strong nuclear force? I think all of you know that inside the nucleus of an atom we find the two kind of particles. One is proton and another one is neutron. Proton and neutron, these are the particles present inside the nucleus. Here protons and neutrons both together will be called as the nucleons. Protons and neutrons both together will be called as a nucleon. Is it clear? Here the force which will hold the nucleons inside the nucleus is called as strong nuclear force. The force which will hold the nucleons inside the nucleus, or else we can define it in another way. The force which will hold the protons and neutrons inside the nucleus is called as the strong nuclear force. So here the nature of strong nuclear force is always attractive force. The strong nuclear force is always attractive force. Okay? That is attractive, strong, attractive force. Okay? And also, this strong nuclear force is a very short range force. Short range force. Means it will not last for a long distance. It will be last for a very small distances, that too in the form of 10 to the power minus 15 meters. ಆ ರೇಂಜಿಗೆ ಮಾತ್ರ ಸೀಮಿತವಾಗಿರ್ತದೆ ಯಾವುದು ಸ್ಟ್ರಾಂಗ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ದೂರ ಎಫೆಕ್ಟ್ ಆಗುವುದಿಲ್ಲ. ಬಟ್ ಆಸ್ ಕಂಪೇರ್ಡ್ ವಿತ್ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್, ಇಟ್ ಈಸ್ ದ ಲಾಂಗ್ ರೇಂಜ್ ಫೋರ್ಸ್. It is a long range force, but the strong nuclear force is short range force. It won't last a long distance. ಭಾಳ ಒಂದು ನ್ಯೂಟ್ರಾನ್ ಇದೆ, ಇನ್ನೊಂದು ಪ್ರೋಟಾನ್ ಇನ್ನೊಂದು ಕಿಲೋಮೀಟರ್ ದೂರ ಇದ್ದರೆ ಅವೆರಡು ನನಗೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗೋದಿಲ್ಲ, ಗೊತ್ತಾ? ಸೊ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಮ್ ಶುಡ್ ಬಿ 10 to the power minus 15 meters. minus 15 meters ಆ ರೇಂಜ್ ಒಳಗೆ ಇತ್ತು ಅಂದ್ರೆ ಮಾತ್ರ ಅಲ್ಲೇ we can experience the strong nuclear force. Is it clear? Okay. The next comes to weak nuclear force. We know it. Weak nuclear force means it is the force between the elementary particles which have been emitted during the radioactive decay. The force between the elementary particle which have been emitted during the radioactive decay. Radioactive decay ಅಂದ್ರೆ suppose you know the radioactive element as uranium. So there we can find the fission reaction and fusion reaction. Fission ಅಂತಂದ್ರೆ the parent nucleus gets into two daughter nucleus. ಒಂದು ಹೆವಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಅನ್ನ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯುರೇನಿಯಂ, ಅದನ್ನು ನಾವು ಒಂದು ನ್ಯೂಟ್ರಾನಿಂದ ಬಂಬಾರ್ಡ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಟೂ ಡಾಟರ್ ನ್ಯೂಕ್ಲಿಯಸ್, ಬೇರೆ ಬೇರೆ ಡಾಟರ್ ನ್ಯೂಕ್ಲಿಯಸ್. ಅದರೊಟ್ಟಿಗೆ ಎಲಿಮೆಂಟರಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಕೂಡ ಎಮಿಟ್ ಆಗ್ತವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇನ್ ಬೀಟಾ ಡಿಕೆ ಇಟ್ ಈಸ್ ಒನ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್ ಆಫ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಸಿಕ್ಸ್. ಸೊ ಅಲ್ಲಿ ಒಂದು ಪೇರೆಂಟ್ ನ್ಯೂಕ್ಲಿಯರ್ನ ಇಟ್ಕೊಂಡು, ಪೇರೆಂಟ್ ಎಲಿಮೆಂಟನ್ನು ಇಟ್ಕೊಂಡು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಡ್ಯೂರಿಂಗ್ ದ ರಿಯಾಕ್ಷನ್ ಪ್ರೋಸೆಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ದ ಎಮಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆ್ಯಂಡ್ ಅ ನ್ಯೂಟ್ರಿನೋ. ನಾಟ್ ಅ ನ್ಯೂಟ್ರಾನ್, ನ್ಯೂಟ್ರಿನೋ. ನ್ಯೂಟ್ರಿನೋ is also an elementary particle. ನಮಗೆ ಗೊತ್ತಿರೋದು ಸ್ಟಡಿ ಮಾಡೋದು ಯಾವುದು, ಎಲೆಕ್ಟ್ರಾನು, ಪ್ರೋಟಾನು, ನ್ಯೂಟ್ರಾನ್ ಅಂತ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಬಟ್ ಅವಷ್ಟೇ ಅಲ್ಲ, we have still more number of elementary particles: electron, proton, neutron, positron, neutrino, antineutrino, pion, meson, pi-meson. These are all some of the elementary particles. Don't bother with them. So here in a beta decay we are going to get two types of elementary particles. One is electron and another one is neutrino. So here the force between these two elementary particles is called as weak nuclear force. Is it clear? However, in the notes I am going to send you the definition of the four forces. Okay? Right.